Okay, returning to the review for Chapter 1, Part B, and this is problems 11 through 14. We're asked here to solve by the elimination method, and I've got these set up side by side, which is the wrong way to do it, so I'm going to show you how we set it up instead for this method. We simply put one above the other like this. So let me get this a little smaller so everything lines up. You can see I've got my x's, y's, and equal signs all lined up. So for elimination, you want to put them vertically over each other like this. Then what you're going to do is try and eliminate the x first, and you do that by trying to find a number that 5 and 3 go into. Well, 5 goes into 15, and so does 3. So my goal here is to make this a 15x and a canceling negative 15x underneath it. To do that, I have to triple that line, and I'll do that right now. Multiplying here gives that 15x like I wanted, and there gives minus 6y. And finally, all the way down here is negative 9. And then I do something similar on the bottom line. I'm going to multiply that line by negative 5 to make sure that we get this value down here. So multiplying across, you get negative 15x, that's good, minus 20y, and then 33 times negative 5 times 33. Let me see what that is. That's 165. Now you add these lines, which will cancel the x out of the problem, and you get negative 26y here, and you get 156 on the other side. Then divide by negative 26 here, and hopefully we get a nice number here. And that turns out to be negative 6 for the y value. Now you're going to substitute that into the first equation, so I'm going to copy that first equation again. And I'm going to put the value of y in on the next line. We know y is now negative 6. A little bit of solving here. Take the 12 over to the other side, or subtract it off both sides, and divide both sides by 5 to get my final answer here. So the answer here is negative 3, negative 6. Remember to put your x first and your y second when you list these points. Okay, next we have another example just like that, and I'm going to go ahead and take advantage of the fact that it comes already ready to go here as far as the format. So I'm going to try to get a 4x and a negative 4x. And in order to do that, I have to double that top line. So that'll give me 4x minus 6y, and then 2 times that 6 on the right is 12. And then when I get to this line here, I've got the right value in place already, so I can just copy that second line. And when we add here, you're going to get 0x, they cancel. 0y, they cancel. And on the other side, you're going to get, let's see, 20, that's 30. So we have 0 times x and 0 times y, that's 0 and 0, is 30. And you get something that's not true, never true. And when you get something that's never true here, that's an indication that you're dealing with parallel lines. So this is parallel. Again, notice how to spell parallel. There's no solution to this system of equations, and this is called an inconsistent system. Okay, another example like this. And let me take a peek ahead. I think this is the last one I have for this. Yeah, this is the last one for this section. You'll notice that the x's and y's are not in the right position, so I'm going to first fix that. Let's see, 4x that's fine, but I need to bring this over to the left side and my minus 3y there, and that leaves a negative 6 on the right. These need to be switched, so the negative 12x has to be in the front and the plus 9y has to be behind it. And now you can see I've got my x's lined up, my y's lined up, and my equal signs lined up. So my goal here is to get a 12x, and I can leave the bottom one just like it is, since we have a negative 12x there already. So we're going to multiply this top line by 3. That'll give us what we want right here. And then when you distribute further, you get minus 9y, and on the other side, negative 18. Now I'm going to copy the next line since it's good to go. And in this case, you get a 0x since those cancel, plus a 0y since those cancel, and these also cancel. So 0 times x is 0, 0 times y is 0, and you get 0 equals 0, which is always true. And that's a hallmark of coinciding lines. It's really the same line twice, which leads to infinitely many solutions. And this is called a dependent system. Okay, that does it for problems 11 through 14, at least the examples for those problems. And we'll pick up on the other side with example K. That is the first of 2 that I have to illustrate numbers 15 and 16 on your review.